Today we're going to review nth roots and then begin solving radical equations. So quick review, nth root means one of n equal factors. So if you're finding the nth root, that's one of n equal factors. So for example, if you're finding the square root, that means one of two equal factors. If you're finding the cube root, that's one of three equal factors. Okay. Just a reminder in terms of vocab and definitions, this is the index, and underneath the radical is the radicand. Okay, so if we take a look at the first example there, just as, again, review, if we have 32x to the fifth raised to the 1/5 power, that means everything gets raised to the 1/5 power. So we could take 32 to the 1/5 and then x to the fifth to the 1/5, okay? Or we could take the fifth root of all of that, 32x to the fifth. So whichever way you prefer. Okay, if we do it this way, that's the fifth root of 32, and then x to the fifth raised to the 1/5 would just be x to the first power if we use properties of exponents. And then the fifth root of 32 means are there 5 equal factors of 32? And so in this case there are. 2 would be the fifth root of 32. Okay. And then we could, of course, solve it from this side as well and get the same answer. So whichever way you prefer. Okay. The second piece of review, we're going to take a look at how to find the fifth root of x to the 7th, y to the 11th. And so in class, we talked about a number of different options for dealing with this. You could rewrite this x to the 7th as x to the 5th times x to the 2. You could rewrite y to the 11th as y to the 10 and then y to the 1, because each of those 10 and 5 for x are divisible by 5. You could try the shortcut that we talked about, which was to take 7, divide by 5, you get 1, remainder 2. The remainder is what goes in underneath the radical. So we've talked about a number of different options. Last year in geometry, you talked about rewriting them as fractional powers, so that you would write x to the 5 times x to the 2. So remember, the exponent rules say that when you're multiplying, you're really adding the exponents, so that's why we're allowed to do that. And then you can take y to the 10 and y to the 1. So you want to just make sure that they are factors of 5. Okay. And then from here, if we raise all of that still to the 1/5 power, that means x to the 5 to the 1/5. That would just give you an x. And then this would be x squared to the 1/5, which we'll deal with in a second. And then your y to the 1/5 would be y squared. And then these are like the leftovers. They would go underneath the radical. So we'd have the fifth root of x squared y. Okay, so just a couple different reminders of the ways that we've talked about doing it. Some of you I know just can go straight to x, y squared, and then the fifth root of, there's 2 x's left over and 1 y left over. So whatever way you prefer, you can do it. Some of you like to think about it as breaking it down into the fifth root. So you could take fifth root of x to the 5 times x to the 2, fifth root of y to the 10, y to the 1. So whatever works for you. Which way is the best way? The best way is the way that's comfortable for you, that you know how to use. Okay? So in terms of rational exponents, rational, remember, just means fractional. So that's why the radical equations is included in the same unit as the rational expressions and rational equations that we just finished dealing with. As a reminder, the denominator of the rational exponent becomes the index of the radicand. So here we had the 1/5, that became the fifth root of 32 x to the fifth raised technically to the 1 power. So if we take a look here at this example, that can be rewritten or is equivalent to the cubed root of 64 to the first power. So number in the numerator becomes the power that it's raised to. So if we look at that for this one, this would be the square root of 4, the index we don't have to write because it's square root, raised to the 5th power, okay? Or as a reminder, we could also write that as the square root of 4 to the 5th. And we talked in class when we dealt with this about the advantages of writing it one way versus another. So here, if you know 4 to the 5th off the top of your head, you could go ahead and do it this way, but most likely it would be a little easier to solve this one, where you have the square root of 4, then raise that to the 5th power, and then you get your 32, okay? And then here, you have to decide, is 64 one of 3, does it have one of 3 equal factors? So is it a perfect cube? Okay, so times 4 is 16, times 4 is 64. So this is a perfect cube. Okay, as a reminder, on the graphing calculator, you would just open a calculator page and we'll do the second or the control, and the caret. And then you could put in the cubed root of 64 and it would give you an answer. Okay. You can also double check that you've done the correct work with something like this. You can put in 4 to the 5 halves. So use your caret, then fraction. And you can verify that that's the same as what we did, which was the square root of 4 raised to the 5th power. Okay. So it's a nice tool for double checking. All right, so that was a brief review. Now we're going to go ahead and start with an example. So radical equations. Radical equation is an equation in which at least one variable or variable expression is under the radical. So for example, okay, we're going to go ahead and go through the process of solving it, and we'll write down our steps as we go. The first step is to isolate the radical, if possible. So I'm just going to say if possible, because there may be a time when it isn't possible to isolate the radical, and we'll take a look at those types of problems tomorrow. Okay, once you have isolated the radical, so we'll go ahead and move that 2 over. Then we'll go ahead and solve using inverse operations. The same way that we always solve equations, we use inverse operations, right? So how do I undo a square root? I would have to square it. Whatever I do to one side, I'm going to do to the other so that I can keep the equation equal or equivalent, okay? And then once I've done that, solving, so a lot of times you might have to raise to the power, but you may also need to multiply by a reciprocal, okay? So a lot of times it's multiplied by power of index, but it is potentially possible that, like in the case of this example, you might have to multiply it by 2/5 so that you can create an exponent of 1, or x to the first power. So raise to power of index or multiply by reciprocal. If you have a rational exponent. Okay. And so technically, once you've done that, this third step will actually be to solve the resulting equation, or solve what you have left, okay? And then the last step is to check. And then we've had a couple of other conversations about this. The checking is actually a required step. It's very important, and we have to make sure we check in the original. So just like when we were dealing with rational equations and you had extraneous solutions, you have the possibility of extraneous solutions in this particular case. So we're going to go ahead and do a quick check. The square root of 16 plus 2, does that equal 6 is our question. Square root of 16 is 4. 4 plus 2, does it equal 6? Yes, it does. So 6 equals 6. This one does in fact check. So then our solution would be identified as 16. I'm going to ask you to go ahead and complete for homework number 2. I'd like you to just jot down a quick definition of extraneous solutions. Just write down also what other types of equations have extraneous solutions from our last chapter. And then I'd like you to try number 3. Okay, tomorrow we will finish practicing with these, and we'll talk about what happens if you have a radical on both sides of the equation and are therefore unable to isolate. We'll also review rationalization of denominators.